so let's talk about naming binary acids. And binary acids are a special type of acid because they are acids that contain a hydrogen and one other element, an exception to that. You're going to name them specifically. It's hydro, root, and then ic, and then you add the word acid. Don't worry, I'm going to walk you through everything. And there's two different roots, though. All the other roots we've used are the same, but there are two roots that are different. S is no longer sulf, it is sulfur for acids, and P is no longer phosp, it's phosphor for acids. So let's walk through how to really approach these different binary acids. Okay, so let's talk about naming binary acids. And we're going to have to think back to our ionic charges or our charges, which I know sounds funny for covalent compounds, but it's kind of a cheat to how many hydrogens there are. But before we build the compound, let's write down the root that we're going to use, because by doing that, we're going to be able to see how everything goes along. So the root of N is NITR. The root of P is phos, but we have to write down the root that we're going to be looking for and using for acids. So it's phosphor. Br, the root of Br is brom. The root of Se is selen. Now, the reason the roots are really important is because the root will, if you're reading it in a name, the root will tell you which element you're using if you're going from name to chemical formula, or if it's a chemical formula, the symbol will tell you what your root is. So the root and the symbol, remembering those pairings, is really key for binary acids. The root of S is sulf, but for acids, remember the root of S is sulfur. The root of F is fluor. The root of Cl is chlor. The root of I is iode, that's I-O-D. The root of SB is antimony. Now Cn, you're probably going, but big C, big N is not a single element, and you are correct. Big C, big N is a polyatomic, but one, it doesn't have an oxygen, and it's one of those exceptions that we do make into a binary acid. And it's the root of big C, big N is cyan, B-C-Y-A-N. AS3 minus, the root of that is arsen. Okay, so the next thing we're going to do is build what the compound will look like in element form. So the reason that it's important to think of the charges is those charges will tell you how many hydrogen you need. So the number, not negative or positive, but that number. So nitrogen has a number of 3 in the charge, so it needs 3 hydrogens. You go H, 3, and then you put in the N. You always put the hydrogens first. So for phosphor, or P3, the charge is 3, so it goes H, 3, and then you put in the P. For brom, or Br1 minus, the charge is 1, so there's just 1 hydrogen. So it's H, and then Br. Remember, capitalization is important when you're writing your formulas, so keep in mind that the H's are always capitalized, and at least the first element of these are capitalized. The second should always be small unless you're doing a compound like cyanide. So for selen, there's 2, so it should be H2. And then you do Se. For binary compounds or binary acids, there's never more than 1 of the second. It's always 1 of the second and then potentially more hydrogens. So for sulfur, it's a charge of 2, so it'd be H2, and then S. For fluor, it's F, so it should be big H, and then F. For chlor, it's Cl1 minus, so it would be H, and then Cl. For iode, it should be H, and 1H, because the charge of iode is 1, and then large I. For antimony, the charge is 3 minus, so you have 3 hydrogens, so it's H3, and then it's Sb. For cyan or cyanide, it's 1, so it should be H, and then this is the one where it's all capitalized because C and N are both elements in their own right. So it's H, then big C, then big N. And then finally, arsen has a charge of 3, so it's H3, and then As. Okay, so let's now talk about how we're going to name binary acids. And binary acids have very easy naming, but they're specific. So every binary acid starts with hydro. That's YHYDRO. Hydro is only for binary acids. Then after hydro, in the same word, you put the root. So it'd be hydro, then you put NITR. Then you ended up with IC. So you make the word hydronitric, and then you add the word acid. So H3N is hydronitric acid. H3P, well, it's binary. There's no oxygen, so I know I have to write the word hydro. Okay, my root of P is phosphor. I add ic, and then I add the word acid. So H3P is hydrophosphoric acid. HBr, okay, no oxygen, so I know it's a binary, so I know it starts with hydro. So hydro, then you do the root, brom, so hydrobrom, and then you end the word with ic, and then you do the word acid. So it's hydrobromic acid. So H2SE becomes hydroselenic acid because every binary acid starts with hydro. Se, the root of Se is selen. You always end a hydro binary acid with ic, and then you add acid. H2S, you start with hydro. The root of S for acids is sulfur. You end with ic, so hydrosulfuric, and you're not complete till you write the word acid. Okay, HF, no oxygen, has to be binary. Binaries always start with hydro. Okay, F, the root of F is fluor, so hydrofluor. I have to end my word with ic, so hydrofluoric, all one word, and then you're not correct until you write the word acid. Okay, HCl, again, no oxygen, it's hydrogen and an element, it's a binary acid. I start all binary acids with the word or the prefix hydro. Cl is my element, the root of Cl is chlor. I end my word with ic, and I write the word acid, hydrochloric acid. Then I have HI, the acid that says high. It's hydrogen. It is an element, neither of oxygen. It has to be binary. All binary acids, I can just write hydro right away when naming them. The root of I is iode, so I write hydro, then I put iode. And then I finish it with ic. And then I write the word acid, so it's hydroiodic acid. Now we have H3SB. Well, again, no oxygen, hydrogen in an element. I know it has to be in binary acid, so I can just write hydro. Antimony's funny though, because it ends at I with that Y. So like when we are doing antimony-ide, the Y you just drop and you just do the IC. So you can just do ANTIMON, and then you do ic, antimonic, hydroantimonic acid, because of those rules of how you drop the double letters. For HCN, this is our example, it's hydrocyanic acid. Sorry, I got excited. And finally, H3S is hydroarsenic acid. Okay, and this is how you do binary acids, naming names to compounds and compounds to names.